Guys, so here's what we're going to do today. We're going to look at how to find the derivative of functions or equations that are written in implicit form. So everything we've been doing so far has been in what we call explicit form, and that form is just what you're used to seeing. It means explicitly solve for y. Y equals 3x squared plus 1. Y equals 2x minus 4. Y equals the square root of x squared plus 3 over x cubed plus 1. So those are explicitly formed. And when we do that, our goal is to find the derivative of y with respect to x. So we want the derivative of y with respect to x. So that's what this became. And over here, because this variable was x, I'm good to go. So that's how that works. So when I asked you to find the derivative, it was the derivative of y with respect to x. So how can we do that when we have an equation like this? X squared plus y squared equals 9. So this is a circle, like from geometry or algebra 2, whenever you studied this. It's an equation of a circle with a radius of 3, and maybe I want to know this tangent line. And I want to use a derivative to find that tangent line. Well, in order to do that, I need to still solve for dy dx. And I use kind of the same technique. So this would be the power rule. So the derivative of this is 2x. In terms of derivatives, it's actually 2x times the change in x over the change of x. Well, the change of x over the change of x is just 1. So that's why we've never written that. So that's why we don't have to worry about that. It's just 2x times 1 plus. So now we have this y squared. So the derivative of y squared would be 2y, like you would think. And we're going to use the chain rule. It's 2y times the derivative of y. The derivative of y is dy dx. And then the derivative of 9 is 0. So our goal, after we do this, is still to solve for dy dx because that's the derivative of y with respect to x. So after you do your implicit differentiation, then you need to do some algebra. So I'm going to move some stuff over, and I'm going to divide. So I'm going to get that dy dx would equal negative 2x over 2y. Those would just cancel, so it would just be negative x over y. So when I start with an implicit equation, my derivative is also implicit. When we took the derivatives before, everything was just in terms of x. So we'd have dy over dx equals, 6x plus 2 or whatever. So now your derivative function is going to be in terms of both x and y because you're starting with an implicit function, something that's not solved for y. So let's try another one and let's see what we got here. Sorry, I'm looking for an example. So like if we had x cubed plus 2y equals y squared. Could we find the derivative of y with respect to x? Our goal is to find dy dx. That's our goal. We're looking for the derivative of y with respect to x. And we're going to solve this implicitly. So I'm not going to solve for y first. I'm going to do the derivative and then solve for dy dx. So x is easy because it's already in terms of x. 3x squared. Plus the derivative of 2y is going to be 2 times, I guess you don't really need parentheses there. So it's 2, and then we need the derivative of y, so it's dy dx. Another way I like to think about it is this is not in terms of x like I want it to be, so I need to have that there. And it's kind of like using the chain rule, like the y is the inside function, it's the baby, equals, this would equal 2y, and then the derivative of the y is dy dx. So now you've done implicit. Now we're going to do some algebra. So notice two terms have dy dx. So I'm going to slide this guy over here. I'm going to have 3x squared equals 2y dy dx minus 2 dy dx. A little algebra trick. They both have dy dx, and they both have a 2. I'm going to take 2 dy dx out, and I'm left with y minus 1. And then remember, I'm going to try to get dy dx by itself. So I want this by itself. So in order to do that, I'm going to have to divide. So I'm going to have 3x squared over 2 times the quantity y minus 1 equals dy dx. That's the derivative. Again, it was an implicit function, implicit equation, so my derivative is in terms of x and y. Let's look at one more here. Let's try this. How about x squared y plus y cubed equals 5x. So in this problem, I'm looking for dy dx. I forgot the directions. There we go. I'm going to start here because this part's easy. The derivative of 5x is just 5. I don't need to multiply by anything because it's already in terms of x. The derivative of y cubed is going to be 3y squared times the derivative of y, which is dy over dx. And now this part right here, you're going to have to use a certain rule for. What rule do you think you're going to use there? If you said the product rule, you're correct. So I'm going to use the product rule. This is going to become 2 terms. Take the derivative of x squared, so that's 2x. It's already in terms of x, so I don't need dy dx, multiplied by y, plus, now I keep the x, I take the derivative of y, which is 1, multiplied by dy dx, because it was not in terms of x. So I got this. I notice this one, these 2 terms have dy dx. So I'm going to take this one and slide it over. So I have x squared dy dx plus 3y squared dy dx equals 5 minus 2xy. Again, to solve for dy dx, I have to use factoring. So dy dx, I factor that out, is x squared plus 3y squared equals 5 minus 2xy. Then to get dy dx by itself, I'm going to divide by that whole expression. So I have 5 minus 2xy over x squared plus 3y squared. And that is my derivative solved implicitly. So you can still, with implicit, you can still use the product rule, the chain rule, the quotient rule, any of the rules, power rule, obviously. So that's kind of a little preview of implicit differentiation. What you're going to do is a little assignment using that.